Alright, today we are looking at projectile motion, which is putting our quadratics into more real-life scenarios. So for now, we're going to do all of this in the calculator or in Desmos. I will show you today how to do it in the TI-84, and then tomorrow for warm-up we will do the problems in Desmos. Either way is fine. Number 1 says a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. So they give us an equation, and our x is going to represent the time, and our y-axis is going to represent the height of the soccer ball. So number 1 says, after how many seconds will it take the ball to reach its maximum height? So this is going to be an x value because seconds is represented on the x-axis. So first you want to go ahead and plug in your equation in y equals and press graph. You will have to readjust the window, so I'm going to go down to my y maximum and try something like 90. Now that might be a little bit too much, but I can tell, oh, it actually was not enough. So then I'll go back to window, go back to y maximum, and let's do 150. It doesn't have to be exact, I'm just trying to get the peak of the graph in quadrant 1. You'll have to do that for probably every problem with projectile motion, is adjust your window. Okay. So it's asking how many seconds will it take for the ball to reach its maximum height. So you're going to press second trace maximum, number 4, enter. And then at the bottom of your screen you'll notice it says left bound. So I'm just going to use my arrow to get somewhere on this left hand side of the vertex. So this is fine, enter. Then it says right bound, so then I hold down the right arrow, get somewhere on the right hand side, enter, and then it says guess, enter. So the maximum height is 126.6 feet. And that's actually what they ask in question 2. And the time is our x-axis that it took to reach that is the x value of the vertex, or the axis of symmetry. So that's 2.8. So those are our two answers. That's how you would answer how many seconds will it take to reach the max height. That's our x value, so that's 2.8 seconds. And then what is the maximum height? That's our y value. That's going to be 126.6 feet for number 1. So this is going to be the axis of symmetry and x value. And then this is going to be the y value, second trace max. So you want to write down what you're doing in the calculator. If you use Desmos, you'll just click the vertex for that one. Okay, domain and range. This is just looking at quadrant 1. So let's do the range first, since we already have that kind of outlined. The ball is never going to go underneath the x-axis, or we don't want to pay attention to that in this scenario because that doesn't make sense. We're looking at a soccer ball. It's not going to go underground. So our range will always be 0 to the very, very top. Again, range is asking where does the graph lie on the y-axis. So our range for this problem is 0 to 126.6. And we'll use brackets for those because both values are included in the function. Okay, our domain, again, we're only going to look at quadrant 1 for this scenario. It's going to be 0, because we're never going to go into negative seconds, 0 to the furthest right point. Where does the graph fall on the x-axis? So for this, I'm going to press second trace 0, and that'll give me my x-intercept. It says left bound, enter, right bound, enter, guess, go right below it. So my x-intercept is 5.6. So my domain is going to be 0 to 5.6. So that would be a good thing to write down for the domain. It's going to be always to your second trace 0 to that x-intercept, and then the range is to the max height for these types of problems. Okay, number 2, let's go back to y equals, clear out our old function, and begin typing in negative 16x squared plus 64x plus 80. So this one's talking about an apple is launched directly upward at 64 feet per second from a platform of 80 feet high. Here is the equation. What is the height of the ball after 3 seconds? So seconds, again, for these problems represents the x-axis. And what is the height of the ball after 3 seconds? So for this one, plug in your equation, press graph. I still have my window from problem number 1, so it works. Again, if you press window, I had changed my Y maximum to 150 to see the top of the graph. If you press zoom 6, you will get back to a standard positive 10 window. Okay, so what is the height of the ball after 3 seconds? So we're going to press second trace value. X equals 3, time equals 3. What is the Y value, or what is the height when we're at 3 seconds? 128 feet. So for number 2, if you're using the calculator, second trace value, type in the 3, and final answer is 128 feet at 3 seconds. So basically you just have to know what to press for each problem. Unless of course you're using Desmos, then we will look at that tomorrow. Okay, number 3. Let's go back, clear out our function, and type in your new graph. Number 3 is a toy rocket. Alright, let's see if our window will work. Go ahead and press graph. Ooh, mine's still graphing, but it looks like the window will not work. So press window, go to your maximum, let's change that to positive 200. And then it says, actually we don't even need to see the top of the graph for this one. So I'm going to stop changing and guessing and checking for that. All we need for this one, it says how long will it take the rocket to reach the ground. The ground is where it hits the x-axis. So again, we're going to press second trace 0 for this one and use our cursor. Get all the way to the right hand side. Remember, zeros are where it crosses the x-axis. Left bound is going to be right above the x-axis. Enter. Scroll down. Right bound, I'm right below it. Enter. Guess. So it hits the ground at 8.09 seconds. Second trace 0. All right, last one for today. Go ahead and type in the equation for number 2. And this one, our window's way off, but let's first see what it's saying. A penny is dropped from the Empire State Building, represented by this function. How long will it take the penny to strike a 6-foot tall person? So 6 feet, again, feet represents, that's a Y value that they're giving us. So how long? So they're looking for seconds. They're looking for an X value for your final answer. That's really what you need to figure out with these questions. Am I writing down a Y value, an X value? Am I looking at the max height or the x-intercept, or the time at the max height, which is an X value? So it's just kind of looking through these equations. You'll always be able to use a calculator for these. All right, so this one, you're going to press second, nope, for this one, I'm sorry, press Y equals, and we will graph the 6-foot tall person in Y2. So again, this is what my Y equals looks like. And this is the last type that you will see. So this is a Y value, 6 feet tall. So right here is where the person and the penny intersect. So how long will it take? Let's press second trace intersect for this one. Get close to that intersection. It says first curve. I'm just holding down that right arrow until I see the cursor. Oh, there it is. And again, Desmos is easier with this stuff. You don't have all these cursors. Second curve, enter, guess, enter. So the penny and the person intersect at 8.8 seconds. So for this one, you want to write down Y equals 6 is what we typed in. Okay. So try a few on the back. The answer key will be posted. A lot of the ones on the back are what we just answered. What is the max height? Would Eva reach a height of 14 feet? We did that one last Friday in the warm-up. So we've done one of each of these, so give these a try. Thank you, guys.